Hi everyone. Last week we learned about square roots and how to approximate and simplify them. And we're going to expand on that and talk about other radicals, because there are other radicals besides the square root. So let's talk about some of those. Here's some examples right here. Now what you notice is you have the radical symbol. Remember, I told you the square root symbol is called a radical, and you still see that symbol. What's different in these is you have a number out front here. I gave you one example with a 3, one with a 5, and one with a 10. That's still a radical, but it's not a square root anymore. It's a different one. So the number to the top left there, the one I put the purple arrow on, that tells you what root you're taking. A square root is a second root, basically, but we're going to be taking a look at some other roots. So I mentioned this just a second ago, but when you take a square root, we usually call it a square root, but it's technically the second root. Now, if I put a 3 there, that's a third root, or what we usually call the cube root. Now, the square root and the cube root have like a name for them, square and cube. The rest of them we just number. So we could say like a 4th root with a 4 on it, or a 5th root, or a 6th root, or a 10th root. I put an etc. on here because they keep going forever. But basically, other than a square root and a cube root, we just number them. Now let's talk about what they mean then. So each radical is the inverse of an exponent. And we already talked about how squaring and square rooting are the inverse. Well, cubing and cube rooting, sometimes you call raising something to the third power cubing it. Well, that's why the third root is called the cube root. So the third root, or the cube root, is the inverse of raising something to the third power. 4th and 4th, 5th and 5th, 10th and 10th. I put an etc. on here again. So basically, the 4th root is the inverse of raising something to the 4th power. So remember when we talked about square roots, I said what a square root is really asking you is what number times itself equals that. So it's the opposite of squaring. And the example, I used 9. I remember doing it in the notes. I said 9 squared means 9 times 9. The answer is 81. That's easy. The square root of 9 is a little harder because then it's asking you what number times itself equals 9. And the answer is 3 because 3 times 3 is 9. Well, we can do that with other roots too. A cube root, or a third root, asks what number cubed, or times itself 3 times, equals that number. A 7th root, I threw in a different number there just to kind of show you it works for anything. A 7th root asks what number times itself 7 times equals that number. And that's what we're talking about here. Instead of taking a number and multiplying it that many times, we're taking the answer to that question and asking what the original number was. So for our example today, what I want to do is I want to evaluate the square root of 64 and the cube root of 64. Because they look very similar, but they have different answers. So let's start with the square root of 64. The square root of 64, and that's a perfect square. 64 is 8 times 8. So the square root of 64 equals 8. Now let's look at the cube root of 64. It's not 8, because 8 times 8 is already 64. If you multiply by 8 again, it's way too big. So we're looking for a number smaller than 8. So let's just try some, since we haven't really done this yet. And go off to the side here. Let's try 2. If I do 2 times 2 times 2, that equals 8. Well, that's not it. I'm trying to get 64. Let's try 3. 3 times 3 times 3. 3 times 3 is 9. 9 times 3 is 27. Let's try 4. 4 times 4 is 16. And 16 times 4 equals 64. So the answer to this question is actually 4. because 4 times 4 is, 4 times 4 times 4 is 64. So this is what you're doing. It's very similar to when we were doing square roots, but you're asking yourself, instead of what number times itself twice equals the number, we're asking what number times itself 3 times equals the number. And I picked 64 on purpose because I knew it would work out perfectly for both of these. Most numbers don't. But 64 is 8 times 8, so it's a perfect square. And 64 is also 4 times 4 times 4, which is what we call a perfect cube. So let's try a fourth root. This is asking me the question, what number times itself 4 times equals 81? So let's just try some again, since we haven't really done this before. Let's start with a 2. 2 times 2 times 2 times 2. And I'm not starting with 1, because 1 times 1, you can multiply 1 times itself a million times. The answer is still 1. So I always start with 2. 2 times 2 is 4. 4 times 2 is 8. And 8 times 2 is 16. So that's not it. That's too small. Let's try the 3. 3 times 3 times 3 times 3. 3 times 3 is 9. 9 times 3 is 27. And 27 times 3 is 81. So we found our answer. The answer to the question is 3. And that's what we're going to do today. For now, we're going to focus on the ones that work out perfectly, where you're just looking at this number right here, and you're saying, what number times itself that many times? Like if I ask you to find the 10th root of something, I'm saying, what number times itself 10 times would equal whatever is inside the radical? And you'd get your answer that way. And then in part 2, we'll talk about when it doesn't work out perfectly, and we'll do the same types of things we did for square roots. We'll do approximating and simplifying.